Hi folks, today we're going to go through the practice exam for Unit 3. The real exam looks very close to this one, so if you're able to follow this and do well in the practice exam, you should be good for the actual unit exam. So I'm going to go through it, and I'll give you my thought process as I go through it, and hopefully that'll help you. So for the first question, it says do not use a calculator. You probably won't need to use a calculator for this section anyway. It wouldn't really help you. But I can't stop you from using a calculator if you want to check your answers or anything. So first off, we need to sketch a number line and mark each rational number on it. Order them from greatest to least. On one of the quizzes, I noticed that people forgot about this step, so make sure you read the questions carefully. There's our number line, 0, and you have to put whole numbers on the number line. You can't just put these numbers, otherwise you don't really have any references to where they are with relation to other numbers. So let's try and space these out relatively equally. There's 1, 2, 3, and then on the other side, 1, 2, 3. Hopefully those are about the same. -1, -2, -3. And then I find it's a little neater if you just put like a letter underneath each one of these. Okay, so now let's start with A, -3.1, so that'd be right about here. So there's A. B is 5/3, so that's 1 and 2/3. So 1 and then 2/3. Okay, so it's going to be closer to the 2 than to the 1, about there. Then the C is -1.2, so there's -1, and 0.2 would be about there, so that's C. D is -1/7, so that's going to be reasonably close to 0, so that would be D. And E is 0.6, which is, there's 0.5 is half, so 0.6 would be right about there. Then when we list them from greatest to least, we just start over here and work our way to the left. So B was first, so that's 5/3. Okay, E was next, that's 0.6. D was after that, so that's -1/7. Where are we? DC is -1.2, and then the last number was A, which is -3.1. In each pair, which number is greater? Explain your answer. Okay, explain. Try to use words, but if you need to, you can use a number line. For these ones right here, I think the best way to do this is to recognize that 6/5 is greater than 1, and 5/6 is less than 1. Okay, so that's a good enough explanation for why this one is bigger. This one here, we got -3.32 repeating, so that's really -3.32222 repeating forever, right? And this one is -3.32. So if you look at a number line, if this is 0, and this is -4, -3.2, would be somewhere in here. Okay, so this would be -3.32. And then if there's more numbers, that means it has to be more negative, so it's got to be just on this side of that. So -3.32. Sorry, it asks which one is greater, not which one is less. So -3.32 would be greater. 3.2 repeating is further left on the number line. That's good enough explanation for that. There's other explanations as well, but those ones work. Determine each sum or difference. Okay, now for these questions, remember you need a common denominator. For addition and subtraction, you always need a common denominator. Okay. Sums are plus, differences sums are adding, differences are subtraction. So I usually just rewrite the question when I see something like this, -3/5. Plus a negative is really just -2/3. Okay, now we need a common denominator. Now there's no way I could turn a 3 into a 5 to make my life easier, so I've got to do it kind of the long way. I've got to take the 5 from this side, I've got to multiply this by 5 and this by 5, and then I've got to take the 3 and then multiply 3 on both on the other side. So 5 gets multiplied on this side, top and bottom, 3 on the other side. So now when I take this a little further, 3 times -3 is -9. 3 times 5 is 15, minus 2 times 5 is 10. 3 times 5 is 15. And again, the whole point of that was so that I get common denominator. So first thing you do is you write the common denominator so you don't accidentally add those, and then you work on the top. So it's -9 and then -10. So we're already at negative on the number line. So if this is the number line, this is 0. We're already over here, and we need to go more that way. So it's going to be a bigger negative number, so it's going to be -19/15. That's an improper fraction because the top number is bigger than the smaller number. So you should get in the habit of writing these as mixed numbers at the very end. So how many times does 15 fit into 19? It fits one time. And then, don't forget the negative. And what's left over? So if I squeeze a 15 into a 19, there's going to be 4 left over. So -1 and 4 over 15 is your final answer there. This one is a subtraction question, but not really. Okay, so these ones convert first, right? Okay, so we've got to convert mixed numbers into improper fractions, and we do that by multiplying. Go clockwise, multiply, and then add. So 8 times 2 is 16, plus 3 is 19 over the original 8. And then this is minus a minus. Let's just make that a plus. Whenever I say minus, it's just plus. Okay, so same thing over here. Multiply, then add. 4 times 1 is 4, plus 1 is 5 over 4. Okay, now this one we can actually take a bit of a shortcut because what you should always check is, can you make the smaller number into the bigger number with multiplication? Yeah, in this case we can. It's pretty easy. 4, we can turn a 4 into an 8 by multiplying by 2. So if I multiply both the bottom and the top by 2, I don't have to change this number. So I can just keep this as 19 over 8. And then over here, I've got 5 times 2 is 10. And 4 times 2 is 8. So I've got common denominator. So let's just write our common denominator here. And then 19 plus 10 is 29 over 8. Once again, we've got an improper fraction. So how many times does 8 fit into 29? It'll fit in 3 times, right? Because 3 times 8 is 24. That's as close as we can get to 29. So if we're up to 24 and we need to get to 29, so that means there's going to be a 5 left over. So 5 over 8. It's a little messy. I'll rewrite that. So it's 3 and 5 over 8. Okay, that's your final answer. All right, we've got evaluate. Okay, show your work. You're going to need to show your work for full marks on the exam, so please get in the habit of doing it. Okay, so evaluate just means find the answer. We've got multiplication. So for these ones, always try to find out ahead of time, is your answer going to be positive or negative? Because it can, and then just drop the signs. So this is a negative. It's a negative times a negative. So our final answer is going to be positive. So now I'm not even going to worry about signs. I'm just going to write numbers. So it's 1 over 4 times 3 over 5. Okay, so that's 3. So that's tops times tops, bottoms times bottoms, right? So that is going to be equal to 3 on the top and 20 on the bottom. 3 over 20. Ooh, messy today. Messier than usual. 3 over 20 is your final answer there. And a lot of people have been checking their work on their exams, I've noticed, and doing it in the margin, just making sure their answer makes sense. It's great. It's a great habit to get into. Okay, now we've got division. We've got a positive divided by a negative, so we know our answer is going to be negative, so let's keep that in mind. Now I'm just going to drop all the signs because they'll just get in the way. And remember that when you are dividing fractions, what you really do every time is you just flip this, right? You multiply and then you flip. So we've got 5 over 6 times 3 over 2. Again, I just dropped all the signs because I already know my answer is going to be negative. Once we get to this point, can we do any canceling from top to bottom? Can't cancel 5 and 2, but I can cancel 6 and 3. So what do I divide out of both of these? Okay, I can divide a 3 out. So if I divide 3 by 3, I'm left with 1. If I divide 6 by 3, I'm left with 2. So now it's tops times tops, bottoms times bottoms, which leaves us with 5 over 4. But I know that's a negative right there. Make sure you check that. Don't forget it at the end. This is an improper fraction, so how many times does 4 fit into 5? It fits in 1 time, and then there's 1 left over, so -1 1/4. Done. Got subtraction here. Okay, but we've got mixed numbers, so let's convert them. So 3 times 1 plus 1 is 4 over 3. Subtract 6 times 1, 6 plus 5 is 11 over 6. Subtraction, so I need a common denominator. Can I easily turn a 3 into a 6 with multiplication? Yes, I can. Okay, if I multiply by 2, so whatever I do to the bottom, I have to do to the top. So what does that leave us with? 2 times 4 is 8. 2 times 3 is 6. And then we don't have to change this one because we've already got a 6 on the bottom. All right, now we can't do any of the canceling with subtraction. You can only do that with multiplication and division. So don't do it with subtraction and addition. Only multiplication and division. Okay. Did I say that properly? Only do it with multiplication and division. Never with addition and subtraction. And this is subtraction. So we just write down our common denominator down here, and then it's 8 minus 11. So we start at 8, we hop 11 back, which takes us all the way to negative 3. So this one we can simplify a bit, right? Because what can we divide top and bottom? Because now the subtraction's done. Now we're at our final answer. Can we reduce this? What's 3 over 6? Well, that's half, right? So if we divide top and bottom by 3, we get negative 1 over 2. So negative half is your answer there. All right, next one is multiplication. So it's a negative number times a positive number. So our answer is going to be negative for sure. Let's convert these. Okay, always convert. 2 times 2 is 4, plus 1 is 5 over 2. Okay, and 3 times 5 is 15, plus 3 is 18 over 5. Okay. So let's look tops and bottoms, see if we can cancel anything out. Again, I dropped the signs because I already know it's going to be negative at the bottom. So I'm just getting rid of all the negative signs because it's not going to, so they don't get in my way. So I can divide 5 by 5 for both of these. So that leaves me with 1 and 1. 2 and 18, I can divide both those by 2. So that leaves me with 1. And then what's 18 divided by 2? It's a 9. So my final answer, don't forget the negative, is going to be negative 9 over 1, which is really just equal to negative 9. Because anything divided by itself, or anything divided by 1 is just itself. Now we've got some order of operations questions down here. So write your bed mass, okay, on the side. And don't forget that when we get to division and multiplication, it's left to right. So once we get to this point right here, it's left to right. Brackets. Do we have any brackets in the first question? Nope. No operations anyway. No exponents. So we're at division and multiplication. What have we got first? We've got subtraction. Then we've got multiplication. So we've got to do that first. So let's just rewrite the first part of the question. Negative 1/7. And then minus. Okay. And now we've got to do this first, right? So minus. Okay. I'm just going to put brackets to make it a little easier. And plus I've got to convert this, right? So 1 times 7 plus 3. So that's 7. That's 10 over 7. Times 1 over 2. Okay. So let's leave this first part the same for now, minus, and then what are we going to end up with in the brackets here? We can simplify this a little bit because it's multiplication. So 2 divided by 2 is 1. 10 divided by 2 is 5. So that makes it easier. Tops times tops, bottoms times bottoms. 5 times 1 is 5. 7 times 1 is 7. Now we're just at subtraction. So we took care of the multiplication, no addition. Now we've got subtraction. And we have a common denominator, which makes it very easy for us. So it's just going to be, we know it's going to be over 7. It's negative 1 minus another 5. So if we're already at negative and we're going 5 more negative, it's going to be negative 6 over 7. And that is your final answer because that is an okay fraction. Next one, we have brackets. So let's start with the brackets. Write out the first part is negative 1 over 2 plus 3 over 5, which we're not going to worry about, and we're not going to worry about the division yet because we have these brackets. So let's look inside the brackets. We've got 9 over 10 minus a minus. Well, that's plus plus, right? So we've got 9 over 10 plus 3 over 5. We have to do what's in the brackets first. So it's addition. We need to find a common denominator. Can we turn a 5 into a 10 with multiplication? Sure we can. It's just times 2. Okay, so this one we have to times 2 on the top and times 2 on the bottom. So negative 1/2 plus 3 over 5 divided by, okay, we know the denominator is going to be 10. Okay, so this part right here, okay, this part right here, maybe I'll do it in 2 steps just to make it obvious. So this is going to be plus, what's 3 times 2 is 6, and then what's 5 times 2 is 10. That was the whole point. We got a common denominator. So that equals negative 1/2 plus 3/5 divided by, and then what we're going to have at the end here is 9 plus 6 over 10. So that's going to be 15 over 10. All right, so we took care of the brackets. Now what's next? No exponents. Do we have division or multiplication? Yeah, we do. We don't have multiplication, but we've got division. So we're just going to, again, we'll just keep this negative 1/2 up front. We're not using it yet. Plus 3 over 5, and then remember, when you're dividing fractions, you multiply and then flip these guys. So it's going to be 10 over 15. Now we have an opportunity to do some canceling here. So we've got a 5 and a 10, bottom and top. So we could divide both those by 5. So that divided by 5 is 1, that divided by 5 is 2. We've got a 3 and a 15, we can divide both of those by 3. So 3 divided by 3 is 1. 15 divided by 3 is 5. All right, so let's just write out our negative 1/2 plus, and now we just can multiply, right? Tops times tops, bottoms times bottoms. 1 times 2 is 2, and 1 times 5 is 5. I think I've done that properly. Yep. Now we've got addition is the last thing we need to do. So if we've got addition, we need a common denominator. There's no easy way to turn a 2 into a 5 with multiplication, so we're going to have to multiply the top and bottom of this side by 2, and then we're going to have to take that 5, and we're going to have to do 5 times top and 5 times bottom. So on this one right here, it's going to equal negative. Okay, so 5 times negative 1 is negative 5. Okay, and this negative just goes with the top. And then what did I have down there? Was that a 5 again, right? So 5 times 2 is 10, plus 2 times 2 is 4. 5 times 2 is 10. So we've got a common denominator here now. So we just write the common denominator. And we've got a negative 5, and then we're adding a positive 4. So we're on the negative side, and then we're going to jump 4 times, which takes us to negative 1. Doesn't quite take us to 0, but it takes us close. So that is going to be negative 1 over 10, which is a proper fraction. Multiple choice. Okay, you do not need to show your work on these ones. I will show you how I would approach these, and some of them I would show work just for my own confidence, and others I wouldn't. Which of these are rational numbers? Okay, we got to remember that a rational number is an integer. It can be written as a fraction where there's an integer in the denominator and a non-zero integer. Okay, that's what I just say, non-zero in the denominator. Okay, it covers all terminating decimals. So decimals that end. And it covers all repeating decimals. And that covers a lot of ground. So let's look at our numbers here. 2 over 11, well, that's an integer over an integer, so that one's good. 3.6, that's a terminating decimal. It terminates at 6, so that one's good. 0.83 repeating, that's a repeating decimal, so that one's good. And 11 over 2 is, again, an integer over an integer. And the bottom isn't 0, so that one's good as well. So all of them are rational numbers. Which of these are equal rational numbers? Okay, so I just take these and I write them by kind of canceling the signs out. Well, a negative divided by a negative, that's really just 3 over 4. Negative 3 over 4, that's written as simply as it can be written. Negative 4 over 3, when a negative sign's either out here or at the bottom or at the top, most people usually write it at the top, and that just makes it easier. So for this one, there's a negative sign on the bottom. I could just move that to the top and get rid of it on the bottom, and then it's fine. It doesn't change anything. This one's out front. I can write it up top. Okay. So if we look at all of these numbers that I've sketched out, which are the same? Okay, negative 3 over 4, negative 3 over 4, negative 3 over 4. So the numbers that are all equal in this one are negative 3 over 4, so that one, 3 over negative 4, so there's 3 over negative 4, and negative 3 over 4, so it's B. All right, let's move on to the next one. On a number line, which rational number, I should probably have those, which rational number is represented by A? Okay, well, A is in the negative side, and all these numbers are negative. Okay, so that's good. How many of these steps are there? There's 1, 2, 3, 4, 5, 6. So each one of these is a sixth, right? So this would be negative 1 over 6. This would be negative 2 over 6. This would be negative 3 over 6. Negative 4 over 6, which makes this one negative 5 over 6. Because negative 1 would just be negative 6 over 6, right? Negative 6 divided by 6, negative 1. So because there's 6 jumps here and the A one was on the 5th jump, it has to be negative 5 over 6. So that's D. Estimate to determine which sum is greater than 0. Okay, so you don't actually have to crunch the data out here if you do a decent job of estimating. So which one is greater than 0? This negative number is bigger than that, so it can't be that one. That's when it's going to be negative. This is a negative and going more negative, so it can't be that one. This is a negative 3.3, and this is a positive 3.6. So the positive number is bigger than the negative number, which means this one is going to be positive. So we know that one works. And this one is negative 3.6 and a positive 2.8. So there's more negatives than positives, so it can't be that one. So it has to be C. Determine the product of negative 3.3 times 6. So we know that negative times a positive is going to be a negative number. So let's just get rid of anything that's positive. Well, that one's out. All right, now, just estimate. It's about -3, right? -3.3 is pretty close to -3. So -3 times 6 is -18. So the answer to this one is about -18, give or take. So it can't be this one. It can't be this one. So it's got to be this one. Okay. So you didn't have to actually do the math to figure that one out. All right, determine the difference between these two. Minus means plus plus, right? So we've got the same common denominator, so we know it's going to be 7, and what's 18 plus 5 is 23. So you knew right away it wasn't going to be the negative numbers. The only question was which of these would it be, and it's A. Determine the product. A negative times a negative, which means it's going to be a positive number, right? So let's get rid of all the negatives, because we know it's not them. And now it's just a matter of estimating. It's about 4 times 8, which is, positive 32. So it can't be this one, so it's got to be that. We didn't have to get the exact number, we just had to get close. All right, whenever I see a whole number like this, I usually just write it, if there's a fraction, if it's a fraction or a whole number, I usually just write it like this, right, 6 over 1, because anything divided by 1 is just itself. So now I'm looking at this, and I'm saying to myself, well, it's positive times a positive, so it has to be a positive answer. So that one's out, and that one's out. So now the only question is, which one of these is it? Okay, well, let's just do a little simplification here. Divide 3 out of both of these, and you get 2 and 3. So 4 times 2 is 8. 3 times 1 is 3. Hopefully that's one of our answers. And there it is, right there, D. Which products are less than 0? Okay, let's do the same thing, like minus times a positive, that's going to be negative. Negative times a negative, that's going to be positive. Negative times a negative is a positive, and negative times a positive is a negative. So which ones are less than 0? This one is, and this one is. So 1 and 4. Hopefully that's an option. There it is, C. Which expression has the same product as negative 5.2 times 2.4? Okay, so this one is going to be a negative times a positive, which is going to be a negative. This is going to be a positive, so that one's out. This one is going to be a negative, so that one's okay so far. This one is going to be a negative, so it's possible. This one's going to be a positive, so it's out. Get rid of that one, get rid of that one. And this one's going to be a negative, so that's positive too. That's a possible too, not positive. So one thing to remember here is look at the numbers, and you see a 5.2 and a 2.4, and you see that here. So it's a pretty good chance that this is one of them. But don't rule out these, okay? Just because they're different numbers than what's up here doesn't mean they won't multiply together to get the same thing. And I'll show you an example of why. If we've got 2 times 6 equals 12, there's other ways to get to 12, right? You could do 3 times 4, or you could do 1 times 12, right? So just because they're not the same numbers as these, you could still get the same answer. So now is probably the time that you can bring out your calculator and actually figure out which of those work. So if we do our calculator, negative 2.6 times 4.8, I believe is 12.48, but I'll just check that on my calculator. So that's 2.6 times 4.8, 12.48. So that's negative 12.48. This one is 1.6 times 7.8, also 12.48, so negative 12.48. And these are the same numbers as these, so I know that's negative 12.48. So, in short, 2, 3, 5 is B. Determine the product. Positive times a negative, it's going to be a negative. So let's get rid of positive answer. Now let's just do estimation. That's about 1, and that's about 8. So, it's a little bit more than 1, a little bit more than 7. So it's going to be about 1 times 8, which is going to be negative 8. So it can't be negative 0.9. It can't be negative 90. So it's got to be negative 9.084. So just, I just use logic for most of these. If you can estimate and use, kind of use your logical side of your brain, you can figure most of these out just by eliminating the others. All right, determine the difference. Okay, this is subtraction, right? But it's a minus minus, so that's really a plus plus. So it's a positive plus a positive, can't be negative. Get rid of those two. It's about 4 plus about 6, so it's probably going to be pretty close to 10. It's got to be more than 8, right? Because 3 and 5 is 8 already, plus you got the decimals, so it's got to be A. Which expressions have the same answer as negative minus another negative? Okay, so this is plus and plus, so we've got a negative and a positive. Okay, so which of these actually looks the same? So really, if I rewrite this, it's negative 12.3 plus 7.8. If I just rewrite this, so I've got a negative 12.3 and I got a positive 7.8, so that one works. I've got a positive 7.8 and a positive 12.3, so that one does not work. I've got a negative 12.3, positive 7.8, that one works, and then they're both negative here, so clearly it doesn't work there. So we've got 1 and 3, which is, whoops, A. Go back up, I'm just checking one here. 1.2 times 7.57 is 9.084. Yeah, okay, that one's right. I feel like I shouldn't have 3 A's in a row there for some reason, but maybe I'm wrong. 3.7 plus 5.9 is 9.6. That's right. And positive 7.8, negative 12.3, positive 7.8, negative 12.3, 1 and 3, 1 and 3. Okay, I guess it's fine. Determine the difference. Okay, once again, we got negative, negative, which is really positive, positive. So we've got a positive number plus a positive number. You know the answer has to be positive, so we're going to rule that one out right away. 8 plus about 4 is more than 4. So it's either 12.3 or 11.3. Well, 8 plus 3 is already 11. And 0.54 plus 0.76 is going to be more than 1. So it's got to be 12 something. So it's got to be D. You can actually do the math if you want right here, but you know, if you could quickly solve it just using logic, why not? Evaluate. Okay, so we got a little order of ops here. Order of ops. So we got to do these ones first. So it's going to be 3.4, right? And then negative 1.4 times, so this is a negative times a positive, right? So it's going to be 3.4 minus some positive number. So 3.4 minus some positive number. Okay, well, these are all positive and we wouldn't know it anyway, so I'll just get rid of that and we might actually have to do the math on this one. So it's 3.4 minus whatever 1.4 times 0.9 is. And, you know, these are easy enough to do in the margins, too. That's 1.26. For instance, if you wanted to do that, you're not allowed to use a calculator. Just go 1.4 times 0.9. Okay, just like in elementary. 9 times 4 is 36. You know, carry the 3. 9 times 1 is 9. That's 12. Okay, and that's a 0, so you don't do anything. Count the decimal places. 1 decimal here, 1 decimal here. So 1 plus 1 decimal is 2 decimals. It's got to be 1.26. All right, so we got 3.4 plus 1.26. Well, 3 plus 1 is 4. So this should be 4.66. Now, I noticed that I don't have the right answer here. This one is supposed to be 4.66. So sorry about that. I'll change that for next year. But it's definitely not any of these others. All right, so let's evaluate this one here. We got order of operations again. So the 5 over the 6 divide is going to have to wait. So we got to do addition here, which means we need a common denominator. How do I turn a 3 to a 6? Times 2. And then so I have to do the top as well. So in the brackets now we've got 2 times 4 is 8 over 6 plus 1 over 6. So now we've got a common denominator here. Let's just leave the 5 over 6 for now and then figure this out. Okay, so that is 9 over 6. Okay, now we know for division we've got to flip if we're doing fractions. So it's 5 over 6 times, flip this one, 6 over 9. Let's cancel. Okay, it's multiplication, so we can cancel tops and bottoms. 6 and 6 clearly both divide out into 1 and 1, which leaves us with 5 times 1 is 5, and 1 times 9 is 9. 5 over 9, that is C. Part 2, you may use a calculator. Show all of your work for full marks. We're going to hold you to that for the exam. Okay, we need you to show your work. The only way we can help you out. Following temperatures were recorded at noon in 1 week. So there's 7 of these things, right? So there's 7 days. So there's all the temperatures. What was the average temperature at noon? Okay, so now to remind you, to get an average, you have to add up all of these and then divide by the number of them. So there are 7 of them, right? Because there's 7 days. So we got to add all these up. So to get the total, we need to go negative 2.3 plus a negative 4.2 plus a negative 1.4 plus 0.5 plus 1.3 plus a negative 0.7 plus a negative 3.8. So we got to jam all those together. You could do it by hand, but in this case, why don't you just use your calculator? Just make sure you got the signs right. So it's negative 2.3, and then minus 4.2, minus 1.4, plus 0.5, plus 1.3, minus 0.7, and then minus 3.8 gives me negative 10.6. So all those numbers together equal negative 10.6. Okay, number of days is 7. So in order to get the average, okay, we got to do negative 10.6 divided by the number of numbers we had, which was 7. Okay, and that is going to give us negative 1.514. I'll just do it to one decimal place here. Nearest tenth, yeah. So one decimal place, degrees Celsius. So the average temperature for that week was negative 1.5. The mean temperature for the month, so now they're giving us another reading, for the month is negative 6.8. Is the mean temperature for the week greater than or less than the monthly? Okay, so this is the weekly. Okay, that's the week average. Is this bigger than or smaller than that? Okay. Well, clearly, negative 1.5, okay, degrees Celsius is greater than, that's the greater than sign, negative 6.8, right? Because negative 6.8 is further to the left on the number line. Okay, so greater than. Next question says, by how much is the mean temperature for the week greater than or less than the mean? Well, we know it's not less than. We know it's greater than the mean monthly. Okay, so the way we got to work here, it's a simple subtraction question, but you got to get the order right. So let's think about this way. We've got a number line. Okay, zero's here. Negative 6.8. Let's just say it's right there. We've got to get back to negative 1.5. Negative 1.5, right? So we're jumping this way. So if we're jumping this way, our number needs to be positive. The difference between these two needs to be positive. Okay? So if we're talking about a difference in temperature, okay, we should probably start with the bigger number and then subtract the smaller numbers. So let's go with negative 1.5 minus a negative 6.8. And what that is going to be is negative 1.5, that's plus, right? Plus 6.8. So the difference between these two temperatures, okay, remember it's going to be a positive jump, right? So the difference between these two numbers is what's 5.3. So that is going to be 5.3, right? Positive 5.3. We're at negative 1.5, and then we got to jump, then we have to jump 6.8, which takes us into positive territory. So 5.3. So what does this mean at the end of the day as far as a sentence? The weekly mean temp is 5.3 degrees Celsius warmer than the monthly mean temp. And you didn't necessarily have to put the subtraction statement in there. That's just the way that I kind of tackled it when I find the difference. If you just, if you went to a number line and said, I know I got to start here, and then I know I got to jump this many steps to get to this number, and you use that to get 5.3, that's fine. Perfectly acceptable. Okay, so there it is. Make sure you study well. Make sure you've got all your homework and your quizzes and your assignments done. And I think most people are doing quite well in this unit. It's probably on par with Unit 2 with regard to the difficulty, which is obviously much less difficult than number 1. So we're looking forward to seeing your exams. And if you've got any questions that we can answer before the exam, please let us know. Good luck.